Hello everyone, my name is Kaan from Yıldız Technical University, and I would like to thank the 5th International Eurasian Conference for giving me opportunity to present my study here. I say this for myself and on the behalf of my thesis supervisor. Today I'm going to talk about effect of aluminum on biodegradable zinc silver alloys. The point of this presentation will be first I will make an introduction. Why do we use biodegradable stands? And I will talk about our objectives and materials and methods. And I will tell you about the results I get from my tests. And I will mix them in together in conclusion part. Firstly, biodegradable stands. There has been an increase in biodegradable stand production because they have an advantage compared to other metal or polymer type stand. These stands start to melt and disappear after a certain time of period after we put them in rain and leave no any residue behind like the other type of stands. As you can see from this picture, you can see this stands are start to dissolve, and because of this there are no need for any second surgery to remove stands from the vein. It's going to dissolve itself after a time, and this affects patients economically and psychologically in good ways. Our objective is to create this biodegradable stand from the zinc silver alloy system and find the optimum alloy system by performing this characterization test which we are running. And these characterization tests are mechanical values, degradation rates, microstructure analysis, and XRD analysis. Those all were investigated and I will tell you all about it. And materials and methods, as I mentioned, we use zinc because zinc has a low melting temperature which is 419 degree Celsius degree, and it's very easy to produce. It does not require special environment equipment. To increase the behavior of pure zinc, because pure zinc's mechanical properties and other properties are rather low. In order to increase them, we alloy zinc elements such as copper, silver, aluminum, manganese. In my work, we use silver and aluminum. Silver increased zinc's yield and shrinkage limit values, and it also increased its antibacterial behavior. And aluminum element increased the values such as hardness and ductility. Now we produced this zinc alloy in our lab in Yıldız Technical University, and we measure them in precision scales carefully, and we are putting them in a graphite crucible. We place them and we are melting them in 590 degrees. We do this 2 times because in order to create the homogeneous structure is very important for our work, and we also use a heat treatment method called homogenization to create homogeneous structure. After we produce them, we replaced them in furnace and kept them there in 16 hours at 350 Celsius degree to create homogeneous structure. After we producing alloy, we are preparing them for our tests such as microstructure analysis. And to do that, we use this metallography test, as you can see picture from below. And we determine phases and grain boundaries in the microstructure. And to do that, the surface to be examined must be very smooth. Now this is degradation test, and it is very important because we are putting this stent into our body, and we need a ratio to say that when will it completely dissolve. In order to determine this time, we are making this degradation test, and the sample we are preparing for this degradation test are 5 mm long and 3 mm in diameter. And this sample prepared were immersed in synthetic body fluid and artificial urine solution. As I mentioned, this is we will put this into body, and to create a body environment, we are preparing this artificial urine solution. You can see the materials we use in here, and we're making this test to rate a amyloid dissolve in our body completely. And now we will talk about the results and discussion. You're seeing here now is a XRD analysis, and I can say this the alloying amounts we use in this study are very low, and there is not enough alloying amount to create second phase. As you can see from the peaks from the XRD graph, all the peaks belong to zincs, and there are no any second phases. And you will see here hardness results. We use Wicker hardness device to determine the Wicker hardness values, and from our literature research we know zinc has 30 hardness Vickers value, and we put them silver 0.5 amount silver. It's the new value is 42 Vickers, and after we put aluminium, it starts to increase until the point 0.5 aluminium. After that, it stops because it's thought to be due to gas particles forming during casting and cracks extending along grain boundaries. And you will see here is microstructure of on the left you see the microstructure of pure zinc. You see these are very large grain and columnar big grains. After we put silver, we can see some globalization, but we can still observe the big columnar grain of zincs. But after we put aluminium, we can see a refinement, grain refinement in the microstructure. And in this picture, we are seeing the average grain size of all the alloys, and the amount includes in moles 0.5 silver has average 444 micron on average, and the one has the most aluminum 0.8 has the 232 micron grain size. As you can see from the picture below, there is a grain refinement due to the aluminium effect. And here you can see the degradation test carried out with artificial urine. The one with the highest aluminium, which is 0.8, has the highest corrosion rate, which is 0.0499 millimeter year. But in general, corrosion rates of all alloys are close to each other. When it comes to the degradation which carried out with synthetic body fluid, the one with 0.6 aluminium has the highest degradation value, which is 0.062 millimeter year. In conclusion, we can say that the alloying amount we use in this zinc alloy are low, and only globalization of zinc was observed, and there are no second phases. And when it comes to hardness, we see that up until the point 0.5 aluminium, there has been an increase observed, but after that no increase was observed. And we can say this: the aluminium has a grain effect, and when we add more aluminium to zinc, the grain refinement was observed. And in degradation test, one carried out with artificial urine, 0.8 aluminium has the highest corrosion rate, and the one carried out with synthetic body fluid, 0.6 aluminium has the highest corrosion rate. And lastly, my thesis supervisor Hakan Mazar is grateful to for the financial report, and our other advisor in Russia, Rinat Islamger, is grateful to Russian Federation Basic Research for the financial support. And thank you for listening to me.